in this chapter, we will continue studying applications of integration, like what we did in chapter 6, if you remember. Here we will study two sections only. We will see here the application of integration in finding the arc length, the length of a curve, and in calculating also the area of a surface. As we did for the volumes, we can do also similar applications for the area of a surface of revolution. I think, Shabab, it is natural. Let me ask you this question. Let's start with 8.1. It is a short section. It is a single idea here. Is about how to find the length of a curve. So let's assume that we are the first people who are thinking about calculating the length of the curve. How can we do that? Any idea, Shabab? Think about it. طبعا, if the curve is a straight line, it is easy. Am I right? Is that correct? If it is straight line,
yes.
we have to find it. How to find the length if it is straight line?
Final minus initial.
Sorry?
Position of final minus initial.
We can treat it as a rectangle or square.
It has a name, Shabab. It is called the distance formula. If you have 2 points, you connect them by a line. The length of this line is the distance between these 2 points. So to find the length of a straight line, it is just you will use the distance formula. Is that correct? Now, what we can do if this curve is not a straight line, it is a curve like that, the one that we have here. So it is a curve, not straight line. Any plan, any idea? Assume that this is an open problem and we are the first people who will solve it.
Maybe, Doctor, we can divide it into small straight lines as we did in 5.1. We divide the curve into rectangle. Here we can divide it into small straight lines.
Allah yarda alayk, ya Sufyan. You deserve a bonus. What is your serial number?
I think 4, Doctor.
Sufyan, you are number 4. You need a bonus. Yes. Thank you, ya Sufyan. You are right. Totally right. So, bonus for Sufyan. Ya Sufyan, you are totally right. Because, ya Shabab, if you remember how we solved the area problem. We divide the area under the area of the region under a curve into sub-rectangles. Then we sum them up. The area of the rectangles, the sum of the area of rectangles will be approximately the area under the graph. The same issue we did with volumes. So here, the idea is quite similar. So here, for example, we will start approximating the length of this line. For an instant, if we draw one line, so we can say that approximately the length of this line is the length of that curve. But if we made two lines, it will be much better. So for example, this here, the sum of the length of these 2 lines is a good approximation, better than the previous one. If we make them 3, it is much better. If we make 4, much better. If we make them n and let n goes to infinity, then this will give me exactly the length of the curve. Great, ya Shabab. So now if I have a curve, I will draw it in the xy plane and I will find out what is the function that it represents. So for an instant, I need to find the length of this curve. So this curve is can be, of course, represented as a relationship between x and y. So it is a function at the end. Y equals f of x. Now to find the length of this curve, or the arc length from the point A to the point B, what we will do, we will approximate it by rectangles. So for example, we will assume here for simplicity, let me take this off. for simplicity, we will assume that we will divide this interval into n equals sub-intervals with the same length. So the length from here to here, let's call it delta x. So here, in fact, it is xi minus xi minus 1. This is delta xi. But since it is the same, we will call it delta x. It is the same for all. It does not depend on I. Let's focus on this typical one, this typical segment. Let me choose another color because we have the red color here. So let's focus on this, yes, Shabab. This line segment. Now this point here, it is xi and yi. And this point here, it is xi minus 1 and yi minus 1. Now we know that the horizontal distance, it is delta x. So here we have delta x. Now the vertical distance, it is delta y, but it is not delta y for all. It is different, yes, but if we choose these points, we'll notice that delta x is the same, but here it is delta y1. So it is different. It depends on I here. So we will call it delta I. What is delta I? It is yi minus yi minus 1. Now, if you want to find the distance between the point bi and bi minus 1, usually we denote the distance between them like the absolute value of this, like this. So what is the distance between them? How to find the distance between the point bi and the point bi minus 1? We will use what? The distance formula. What it will be? It will be, of course, xi minus 1 all squared plus y minus yi all squared. And this, if indeed it is what? This is delta x all squared, and this is plus delta yi all squared. So as Sufyan said, this is of course the idea to find the length of the curve. We will find the length of all the line segments. So assume that we have n line. So we will find the length of each line, then we will sum them up, then we will make the limit. We will let n goes to infinity to have the exact length. If you remember, Shabab, this is the limit of a Riemann sum. So we have a Riemann sum here. This is a Riemann sum, and this is the limit of the Riemann sum. For the notation, we know that this is, of course, integral. The limit of the sum is an integral. This is the definition of the definite integral, if you remember, Shabab. It is good to revise chapter 5. And we need now, our task now is to find the formula for this. What is bi minus bi? We are close. We have a formula here, but we need to work on it more. So it will be an integral. The length of a curve will be a definite integral. How to do that? Let's continue. So now what I will do is I will continue simplifying this. So now delta x, I will keep it as it is. Delta yi, since it is different from a line to a line, from a segment to a segment, we need to work on it. If you have a Shabab, y equals f of x. What is dy as a differential, if you remember? It is f prime of x dx. Am I right? So you can do the same for the differentials if it is like this. So delta y will be f prime of x delta y, your delta x. You can say like this. So when it is yi, you can say here xi and so on. So according to that, or you can use the main value theorem, by the way. You know that from the main value theorem for this in the interval from xi minus 1 to xi, that the difference, this is yi and this is yi minus 1. The difference between them is delta yi, and this is of course a point between xi and x minus 1, and this is delta x. So in short, we can replace here delta yi by f prime of xi delta x star. Here is any point between xi and xi minus 1. Now, if you look here, we replace delta yi by f prime delta x. Now we can we can square here. So if you squared, what you will have? You will have f, let me square for you here. It will be delta x all squared plus f prime of xi star squared, and also delta x all squared. Then take delta x as a common factor. So what you will have? You will have 1 plus f prime of xi star, and here you will have delta x all squared. Then distribute the square root, so it will be the square root of this and the square root of delta x. Delta x is the distance between xi and the xi. It is the length of this interval. So it is positive, so we can cancel this without absolute value. So we will have this times delta x. So this is the length of, or the length of the typical segment, line segment. Now this is for 1. We can now make it for n. So now this is the length of the typical line segment. This is what we obtained. Now we will sum it up and then take the limit. If you look at this, do you remember the definition of the definite integral, ya shabab? What is this? Who can remind me the definition of the definite integral? If you have a function, the integral from a to b for h of x, for a function, let's say g of x, dx. This is equals to the limit of n goes to infinity for sigma I start from 1 to n for what يا شباب؟ الشباب اللي ذكروا شابتر 5
gx5
g of xi or x star, any point, okay, delta x. This is the definition يا شباب of what? This is the definition of the definite integral. So according to this, what is this? The limit of the sum. This is the limit of the Riemann sum. This is the integral. The integral from where to where? We started, if you recall, we started from a to b. So here it is. And this will be the square root of 1 plus f prime of x delta x dx. Here it is. Just we are applying the definition of the definite integral. Okay? So by the definition of the definite integral, the length of this curve or the arc length is given by this formula. This is the summary. I will summarize it here for you. So if you have a curve of a function and you want to find the length of the arc from a point A to another point B, then just integrate from A to B the square root of 1 plus the square of the derivative. Because we have a first derivative here, this derivative must exist and must also be continuous, because to guarantee that it is integrable, you know, if the function is integrable, then if the function is continuous, it will be integrable. So if the derivative is continuous, then its square is continuous. When you add 1, it will be continuous. When you take the square root, it will be continuous. So this is a continuous function. So the integral exists. That's it. طبعا if we will use Leibniz notation, and instead of f prime we will use dy dx, because it will be more easier to deal with the differentials better than the notation or Newton notation. Let's take an example. I think find the length of this curve from this point to this point. So this curve is a semi-cubical parabola. So from y squared, from 1 and 1, from this is x, this is y, to 4 and 8. Now let's apply this definition now. What we need to do, ya shabab, to find the length of from this point to this point, we need what?
find xi.
We need delta y, delta x. Then we will square it. Then we will add 1. Then we will take the square root. Okay. Now the question here, we can of course integrate with respect to y or with respect to x. You can solve this equation for y and you can solve it for x. So what do you prefer to do? By the way, you have x, you have y. If you want to integrate with respect to x, you will integrate from 1 to 4. If you want to integrate with respect to y, you will integrate from where to where? From 1 to 8. If you want to integrate with respect to y. So it is up to you, ya shabab. Solve this equation for y or solve it for x. let's solve it for y. So according to that, what we will have? Square root. It will be here what? Y equals to positive or negative, the square root of x cubed. But because here, ya shabab, x is between 1 and 4, also y between 1 and 8, it is positive. We are in the first quadrant, so it is positive. So in other words, y equals to what? X to the power 3 over 2. Y equals to x to the power 3 over 2. Now this is y. What is dy dx or y prime? It is 3 over 2 x to the power a half. Am I right? What is good about this formula, shabab? It combines math 101 with math 102. You have the derivative, you have the integral. So be careful when you integrate and differentiate. Now this is dy over dx. Now next, what we will do, we will square it. So it will be what? 9 over 4x to the power 1. Now what you will do, you will just substitute here by 9 over 4x. Here we are. This is y. This is the derivative. Square it. This is what you have. Now, after this step, it is not chapter 8 anymore. This is an integral that you should be able to evaluate. Now, how to evaluate this integral, ya shabab? For me, I can do it this way. Is that right?
Yes, use a U substitution.
I did it mentally. I used the U substitution mentally. Because if you are going to use the U substitution, what you will put U equals? You will put U equals to 1 over 9 plus 4x. If you notice, du will be 9 over 4x dx. The derivative of x is 1 dx. Dx will be what? Will be 4 over 9 du. So now this is the 4 over 9 that I came from. I bring here. And what I will do after that, I will have the integral of u du. So it will be just, you will add 1 and divide by the new power. So it will be 3 over 2 multiplied by 2 over 3 after the integration, which is the same. Of course, I expect from you, ya shabab, after this long weeks we are integrating to be able to do it. But of course, if you are not, you can use the U substitution. It is more guaranteed, of course. You need also to change the limits of the integral. So here is the what you need to be careful about. And of course, ya shabab, you need how to do that, how to calculate. It is just the upper minus the lower. This is the final answer. You can approximate it if you want to use a calculator to approximate it. So the length of this line or this arc is about 7.6 units. Now, as I said before, shabab, this one, the previous example, we can solve it for x. We can write x as a function of y. And then we can find the derivative of x with respect to y, which will be the derivative of y. So if we have x as a function of y, and it is easier to solve for x, and you know y from where to where, then you can apply this integral, of course, provided that the first derivative is continuous. So now the integral of 1 plus g prime all squared will be equals to the same. Whether you use that method or this method, you integrate with respect to y or with respect to x, it must be the same length. Let's take this example. Let's find the length of the arc of the parabola y squared equal x from the origin to the point 1 and 1. Okay, so what we will do, ya shabab, it is, I think you can integrate with respect to x or with respect to y, but it is ready here. We have x equals what? Y squared. So dx dy will be 2y. Square it, then add 1. What you will have? You will have 1 plus, or let's call it whatever, it is 4y squared plus 1. under the square root. Then you will integrate this. Now we have here, we will integrate with respect to y. We have it as a function of y. So now the length of the curve, x equals y squared, this is the x dy. The length of the curve will be the integral from 0 to 1. X is 0 or y is 0, both of them. We will integrate from this y to this y because we integrate with respect to y. So this is y value. The integral of 1 plus 4y squared, this is the same as this. Now, خلاص, chapter 8 is done. 8.1 is done. What is remaining now is just chapter 5 and chapter 7. Now, how to find this integral, ya shabab? Wake up, please. I will ask some of you, ya shabab, to do that. Where we have stopped last time, let me ask Abdullah Abdul Salam. Yeah, Abdullah Abdul Salam. Abdullah, are you with us? Abdullah Abdul Salam. Abdullah Abdul Salam is absent. This is section 59. We have Abdullah Abdul Salam absent. Okay, let's go to the next one. Hamad al-Dial. How to find this integral, ya Hamad?
Yes, mister.
Yes, ya Hamad. How to evaluate this integral? You are 1 week, ya shabab, from the exam.
Is it we take a tan?
Sorry,
We take
what is called? My variable here is y, so we will both y equals what?
y equals a tan theta.
What is a?
A is 1.
A is 1, so we will both y equals to tan theta.
Yes.
You are right in using the trigonometric substitution. You are good, ya Hamad. Because here you thought about the integration by trigonometric substitution. I was waiting for you to say these words. We will use trigonometric substitutions. How? Indeed, what you did is wrong, is not correct. So what I want you, Shabab, to say that, yes, here you need to use the trigonometric substitution because here you have, ya Shabab, 4y squared. If it is like this, you will use u substitution. It is easy because if you put u equals to 1 plus 4y, du will be 4 dy. The problem here, if you put u equals to 1 plus 4y squared, du is not there. Du will be 8 y dy. You don't have y inside this integral. So this is why the u substitution doesn't work here. So you need to use the trigonometric substitution, but not as Hamad said. We need here to use what? Y equals
factor.
what?
1 over 2.
1 over 2. Yes, you are right. Y equals 1 over 2 tan theta. How and why? Indeed, you can do it in 2 different methods. One way is to say that, I know you need to, Shabab, to write down here what you recall, what you know. You know that if you have a squared plus x squared, then you will put x equals to a tan theta. Okay? If it is y here, you will put y. It is not a big deal. Okay? Now the question is, the coefficient of y squared here is 1, but here it is 4. So what we can do, we can take 4 as a common factor. So it will be 1 over 4 plus y squared. So it is so easy. And this, of course, will be equals to the integral from 0 to 1. The square root of 4 is 2, so it will be out. And here you will have the square root of 1 over 4 plus y squared. And I think now you know that a squared is 1 over 4. So this is why you will put a equals to a half. Understood? Is it clear, Shabab?
Yes, sir.
Or I think, I'm sure that I told you about generalizing, ya Shabab, what you learned before. Now, if I have square root of a squared plus b squared y squared or x squared, what I will put y equals to or x equals to? I will put it to A over B, tan theta. You can generalize about this also. You can do the same for sine and for secant, for the other trigonometric substitutions. So this is what we did. It is 1 over 4. But this one is more safe, of course, for you if you don't recall how to do that. No problem, just make the coefficient equals to 1. Okay, great, ya shabab. So this is my substitution, y equals to a half tan theta. What we will do next, ya Ahmed Suwaiket. Ahmed Suwaiket.
Yes, teacher.
Yes, ya Ahmed. Next, what we will do?
I don't know, teacher.
Really? We
Yes.
said we will use this substitution. So what we need to do after this? Ahmed, you are 1 week from the midterm exam. لا حول ولا قوة إلا بالله. خالد الحربي, يا خالد. Khalid or Muhammad al-Harbi, I don't know. Did you change your name? Muhammad al-Harbi, yes.
Yes.
So, yeah, Muhammad, what do you think? What we will do next?
About y equal half 10.
Yes. Now we need to evaluate this integral. We say that we will put y equals to the half of tan theta. Next, what we will do? So what?
Differentiate.
So we will find what?
dy.
dy, yes. Yes. Why you are afraid, ya shabab? Don't be afraid. Anything come to your mind, say it. Do mistakes inside the class. It is better than doing mistakes in the exams, please. So you will find, now you know what is y, you need to find dy. What is dy, ya Muhammad?
Sec square.
Secant squared theta d theta. Yes. Yes. You need to be more faster, ya Muhammad, please. So now we did find y, we did find dy. What is remaining now? What we will do next? Turkey, what we will do after that?
Substitute y and dy.
Yes, substitute dy and dy. So we will have what? Square root of 1 plus 4 multiplied by 1 over 4 tan squared theta, and dy is a half of secant squared theta d theta. There is something missing. From 0 to 1?
Yes.
No, ya Turkey. Not from 0 to 1.
No, we bring the new values in the new substitution, new limit.
This is what I expect from you to tell me. So now you need Shabab here to find the new, to change the new limit. So y it was 0 and 1. Now
Yes.
what will be theta?
It will be 0 and
if y is 0, it will be tan theta equal to 0, then theta is 0. You are right. Now
Yes.
if y is 1,
pi over 4.
No, tan theta will be 2. Be careful.
Sorry, yes, 2.
So theta will be the tan inverse of 2.
Tan inverse, yes.
So this is tan inverse of 2. We don't know what is tan inverse 2. Now we will simplify, Shabab. This 4 will be cancelled with this 4, and you will have 1 plus tan squared. 1 plus tan squared will be what?
Secant square.
Will be secant. So we will have this. These are the details. Well, this is y, this is dy, this is the square root. And of course, these are the limits. Because here we have theta equals to tan inverse 2. Look, when we integrate, it is not practical to write this here. So we will do a small trick, and I want you to learn this trick. But call it alpha. Call tan inverse. It is angle. At the end, it is angle. Call it alpha. Don't call it theta, because theta you will use it. You will use it as a variable of integration. So it is from 0 to alpha. What is alpha? Here it is. This is alpha. Alpha is tan inverse 2. And this will make the calculation easier for you. Now, this is the radical. This is the dy. Simplify. You will have secant cubed. What is the integral of secant cubed, Shabab? I think this is the fourth or the 5th time we mentioned this integral. So I think it is not bad to add it to your basic table of integrals. What is it? Who can recall? Who can tell me what is the integral of secant cubed? This is 7.2, example number 8. For me, I do remember it. It is the half of secant theta tan theta plus ln secant theta plus tan theta. That's it. This is this integral. It is equal to this. We did it, ya shabab, several times. It is not practical to do it every time because it is repeated, and the proof, by the way, is long. So if you remember, we used integration by parts. We write it as secant theta, secant squared theta, d theta, and then we use by parts, and then we add it from one side to another side. So here it is. Just you need to recall section 7.8, example number 6, section 7.2, example number 8. Now it is time now to integrate upper minus lower, to evaluate upper minus lower. For the upper, you will replace theta by alpha. For the lower, you will have secant theta, secant 0. Secant 0 is 1, tan 0 is 0, so this will be 0. Here you will have 1, here you will have 0, ln 1 is 0. So everything will be 0 for the lower limit. So we'll end up with the last limit. Now, what is secant alpha? Tan alpha, we know what is it. What is tan alpha, shabab? We know that alpha is tan inverse. We know that tan inverse alpha is 2. So tan alpha is 2. We know that alpha is tan inverse 2. So tan alpha is 2. Now, tan alpha is 2. This is 2. Now, secant alpha, you can find it from the triangle. You can draw the triangle. If tan alpha is 2, this is alpha, not theta. This is alpha. This is 2. This is 1. This will be the square root of 5. Or use the Pythagorean identity. Secant squared will be 1 plus tan squared. It will be 1 plus 4. It will be 5. Secant alpha will be the square root of 5. So this is square root of 5. And of course, you can now simplify. You can just substitute secant alpha by 5 and tan by 2. And this will be the length of this curve. Another example, shabab, find the area or set up. Oh, he just here set up the integral, not evaluate. Do not evaluate the integral. So set up an integral for the length of the arc of the hyperbola. I don't know why he called this hyperbola. It is not a hyperbola, by the way. In the same properties, it doesn't have the same properties for the hyperbola, but it is similar to. So now y equals 1 over x, or x equals 1 over y. It is rotated indeed, rotated hyperbola. Okay, now it is y over 1 over x, and x is 1 over y. You can here integrate with respect to y or with respect to x. It is up to you. Okay, it is similar. So he bought y equals 1 over x. Now find the derivative, square it. You will square this derivative. It's square. Then that's it. You can stop here. If you want to be more gentle and of course simplify, here it is. Now, of course, this integral is not easy to be evaluated. So this is why he said set up. Stop here and just set up. But of course, you may find other method to calculate. The last part of this section, shabab, is about the arc length function. We can have it as a function. How? If you have a curve, if you have a point here, let's say A up to B, the another point is B. So here, this is f of A and f of A. This is B and f of B. The length of the curve will be the integral from A to B for the square root of 1 plus f prime, if this is y equals f of x. F of x prime all squared dx. Okay? Now, what about if I replace B by x? So I want to find it at any point x here. So if we replace here by x, so it is not practically, shabab, to have here x and x here. It is x the variable of integration. Here x is the upper limit. So to avoid this confusion, we will use any letter other than x. Let's say t, for example. Now, because here we will integrate and then we will substitute upper minus lower, this at the end will be a function of x. It depends on x. So this is why we call it a function. So now I can find the length at the end as a function. Let's call it s of x. It is a function of x. Just give me your x and I will give you exactly what is the length of that number. Okay, so look what will happen now. We will do something that is useful not only for this section, it is also useful for the next section, 8.2. Do you remember how to differentiate an integral, ya shabab? If you have integral, to differentiate
Substitute by x.
the upper, this is the fundamental theorem of calculus. So now the derivative of s, it is ds dx. So the derivative of this integral with respect to x will be just the value of the integrand function at x. And this is, of course, you can replace f prime by using the differentials or the Leibniz notation as dy over dx. Okay. This should remind you, let's multiply both sides by x, because this is a differential. So if we multiply both sides by dx, look what we will have. ds, s is the arc length function. This is s. ds is the square root of 1 plus dy dx all square dx. This I think you can remember what is this. Did you notice what is this? It is the integrand. It is the integrand of the arc length. When we calculate the arc length, this is exactly what we have there. So we can replace this by ds. So we can say that the length will be the integral of ds, where s here is the arc length function. So this is the more general definition of the arc length. It is the integral of the differential of the arc length function. I will mention this in the summary. Now, look what we can do here. We can go from integrating with respect to x to integrating with respect to y. How? Just square both sides here. If you square both sides here, what you will have? This squared, this will come, and you will have ds all squared equals to 1 plus dy dx all squared multiplied by dx squared. Then you can distribute. This will be, of course, dx all squared. This will be cancelled with this, and you will have dy all squared. This, I think, should remind you about the Pythagorean theorem. So if you have here, this is delta x, this is delta y, this is delta x, delta s. So if it is the length of a curve like this, so you can just approximate the ds to be dy dx. Of course, this is easy for you to recall the relationship between these, x, y, and ds dx, dy. Now, of course, now you can solve this for x, you can solve it for dy, for whatever. Let's do it now. Here we integrate with respect to x. If you want to write it in terms of dy, what you can do? You can take here dy as a common factor. So what I can do here, it will be dx over dy all squared plus 1, and I will take this as a common factor. Okay? Then you will take the square root. This is ds all squared. Take the square root. What you will have? You will have ds equals to all of them are positive because they are length. The square root of delta x delta y all squared plus 1 delta y. So it is the same as this formula, but here with respect to y, here with respect to x. And this is another formula for ds. You can see that we can write ds, the differential of the arc length function, in this way or this way. This is if you want to integrate with respect to x. This is if you want to integrate with respect to y. This is very important, Shabab, not only for this section, as I said, it is also for 8.2. So what we can conclude, Shabab, from here, that the length of the arc length is equal to the integral of ds. The integral could be from a to b or from c to d. It depends on what you are integrating with. So it is the integral, the definite integral of ds. What is ds? ds, it could be this if you want to integrate with respect to x, or this one if you want to integrate with respect to y. Let's apply it here. Find the arc length function for this curve. taking the point 1 and 1 as the starting point. So here you will find the length of the curve from 1 and 1 up to where? Up to x and f of x, to any point, not necessarily to a specific point. So what we will do again, this is why you will find the derivative. And there is a nice trick here that I want you, ya shabab, to focus on. When you differentiate, this is the derivative, of course, this is clear. Now, what you will do next, you will square this. So you will find the square of f, then you will add 1. Look here, this is a perfect square, ya shabab. Perfect square. You will expand it. When you expand it, it will be 4x squared minus this times 2. You will have negative half plus the square of this one. Notice here that what you will get later, 1 minus a half is what? Is a half. So you will have this plus a half plus this. Now, what we will do next, we will take the square root. So what will be the square root of this? It will not be easy for you to integrate if you have a radical of this type. But what I want you to notice here, that this was written like this as a perfect square. So what is this until this? This is equals to what?
The same with the positive sign.
Yes, exactly. This is 2x plus 1 over 8x all squared. This is a perfect square. And this will make it so easy for you to integrate. When you take the square root of this will gone because x is positive. So this will be gone and you will have 2x plus 1 over xa. Without this trick, ya shabab, you will be stuck. You will ask yourself, oh, what is this integral? How to find it? I cannot. You may waste your time if you didn't realize this trick. So please pay attention to this trick. It is one of the most repeated tricks in finding the arc length. What is remaining, ya shabab, is so easy. You will just integrate from 1 to x because you need to find the arc length function for what you have. So this is now, you will replace, of course, f of x is this with x. It is 2x plus 1 over 8x. Now this, of course, you need to integrate with respect to t. So it is 2t over 1 plus 8. Now integrate. The integral of 2t is 2 squared, t squared, plus 1 over 8 ln t. And you can notice that, of course, you will substitute upper minus lower. And this is the arc length function. So it is a function of x. Now the distance from the point 1 and 1 to any point x and f of x, it is equals to this. Give me any point. For instance, if you want to calculate the area or the length from the point from 1 to 3, here it is. Just put instead of x 3, and you will have it. Yes, yeah, Sultan, what do you want?
معليش مستر بس فصل النت وطلعني من الميتنج ورجعت دخلت.
After the class, this is not the time to talk about that. Sultan now. Okay. Now, I think you got it, ya shabab. This is, of course, the end. This is 8.1. This is all what we have in this section. Let's go about what we have next. Here, ya shabab, I have added some solved exercises and some exercises with the final answer. Like this, you can solve and check your final answer. This is an interesting one also. This is also find the length. Of course, most of the questions are find the length, what they will ask you about. But of course, there are, for example, like this exercise. It is an interesting one, but easy. He will give you the function of he will give you the formula, and he wants to find the curve. What is the curve? So what is the curve that its length is given by this? So just you need to compare it with the formula, the general formula. So in this case, what is this? It is y prime squared. So you will say that y prime squared is 1 over 4x, and you will try to find what? You will try to find what is this? What is y? So I will leave it for you. The final answer is here, by the way. Now, as Zubda, this is the summary of this section. This is how to find the arc length, and of course it will be much easier to be memorized like this. The length will be the integral of ds. It could be from a to b or from c to d. It depends on, are you going to integrate with respect to x or with respect to y? Okay. Do we have time? I think we do. So let's solve this recitation exercises. But I will delay the recitation exercises to the next class. Let's solve. Let me go to have one of the old exams that is about the trick that I told you. It is not. This is similar to what is. So let's take this one. Yes, if the derivative of the function is this, then what is the length of the curve from 0 to 1? Good one. So you need to recall here the formula. The length is what? The integral from 0 to 1, the square root of 1 plus f prime of x all squared dx. So it is easier than you don't need even here to differentiate. It is there. What is given for you is the derivative, not the function. So this will be equals to the integral from 0 to 1, the square root of 1 plus the derivative is this one. You need to square it. When you square it, the square root will come, and this is the x. This is equals to the square root from 0 to 1. This is gone. This will be 0. So we have here what? 4, the square root of 4 e to the power 2x dx, which is the integral from 0 to 1 to e to the power x dx. Is that correct? Which is 2 to the power 1 minus 2 to the power 0, which is of course 2 to the power e minus 2. Let's see if we have a different formula. This is similar to what I told you, Shabab. This is a good one. Look here, when you differentiate, what you will get when you square, then add 1. Look, this is perfect square. When you expand, this is what you have. When you add 1, this is what you have. You should write it again as a perfect square to be able to make it easier. Otherwise, you will waste your time. This is similar to what we did. This is similar to the example that we had. Length secant. This is the curve. Let's solve this one, Shabab. So what we need to do, we need to find the length of this curve. What is y prime? Who can help me finding y prime, Shabab?
Secant tan over secant.
It is secant x tan x over secant x, which is what?
Tan x.
Tan x. Okay. So now square it, then add 1. So it will be 1 plus tan squared x. What is it?
Secant square.
Secant squared x. Now take the square root.
It will be secant.
So it will be the length of the curve will be the integral from 0 to pi over 4, the square root of secant squared, which is secant squared. You need to be careful here. The square root of secant squared. It will be the absolute value. But you need to ask yourself, is secant squared positive? It is positive. Is secant positive between 0 and pi over 4? It is positive. So now it will be, of course, secant x dx. And of course, this is easy. This is ln secant x plus tan x. And it is from 0 to pi over 4. Calculated, you will get ln 1 plus square root of 2. Any question, Shabab? Next class, inshallah, we will solve the recitation exercises for this section. We have, I think, only 3 or 4 exercises, recitation exercise for this section. Get ready, ya Shabab, for the next class. In the next class also, we will have at the end of the class, inshallah, 2 quizzes at the same time for 20 minutes. Quiz number 4 and quiz number 5. See you, Shabab. Have a nice, hard working weekend.
Doctor.
Yes.